Electronic Control and Digital Electronics, Level 4, Topic 1. Module 3, Session 3.1. In this session, we will be discussing resonance, a concept critical to the understanding of RLC circuits. We will then do a practical activity on building RLC circuits. Resonance is a condition that will occur in a series or parallel circuit when XL equals XC. Resistance plays no part in the resonance of a circuit. The formula to calculate the resonant frequency is F equals 1 over 2 pi square root LC. But why is the resonant frequency so important? We can explain this using the example of radio signals. The antenna of a radio receiver is receiving signals from many radio, television stations, and emergency services all at the same time. Each station broadcasts at a different carrier frequency. For example, Gagazi broadcasts at 99.99 MHz FM and East Coast at 94.4 and 95 MHz FM. Each different frequency induces a signal voltage in the antenna so that at any given time there may be many different signal voltages in the same antenna. So how can we separate the signal we want from the other signals? We can separate one frequency from the rest if we can find an inductor and capacitor combination which resonates at same frequency as the one we are trying to separate. Only this frequency will encounter zero impedance and will therefore produce a large current. All other frequencies will encounter large impedances and the currents at these frequencies will be practically zero. The tuner of the receiver is a series or parallel circuit consisting of an inductor and a capacitor, which we can make resonant at different frequencies by using a variable capacitor, or today, a Varactor diode, also called a Varicap diode. A Varicap diode selects and passes on the required frequency to the amplifier system, and you have now tuned your receiver to the required radio station or TV channel that you wanted. There are many other uses for resonance circuits. This is why it's so important to understand how they work. Band pass, low pass, high pass, and other similar circuits all use the principle of resonant circuits. Here are some practical applications for resonant circuits. Tuning circuits. Radio and television stations as well as other applications where a specific carrier frequency is needed such as emergency services use resonant circuits. Metal detectors. Every metal has its own resonant frequency. RLC circuits are used to identify such metals. Filter circuits. These circuits are used to block certain frequencies and allow others through a circuit. We are now going to do a practical activity on constructing and interpreting series and parallel circuits. Your facilitator will hand out the equipment you need to do the practical task. Refer to your workbook for the instructions. Let's now take a moment to discuss how you found the practical activity. What challenges are your students likely to face when asked to do a similar activity in class? What would you do if your campus did not have all the necessary equipment? Take this opportunity to brainstorm possible solutions with your colleagues. End of Module 3, Topic 1.